Okay, hey guys. So welcome to this video, and as we discussed in class, in this video we are going to see how we can actually debug a code, okay, an assembly code. So the goal here is to learn how to use a specific debugging tool, which is the x32dbg tool. It's important to remember that you must have watched the class about debuggers, right? The class that introduced you to the concepts involving how and when to use a debugger. So you have to understand things as what is a breakpoint, what is a debugger, okay? The different types of debuggers, but most importantly, the different understanding the concept of a debugger, the differences between a debugger and a disassembler, such as Ghidra and IDA Pro, and what is a breakpoint. Okay, with that being said, in order to see how we can actually use a debugger, we are going to use the same code, password.exe, the same malware file, password.exe, that we used for before our previous lab, before lab 6. Okay, so again, as I mentioned in class, you're going to see here the material that you're going to need, the application that you're going to need to solve lab 7. Okay. Now, in order to solve lab 7, you are going to use this debugger, specifically the x32dbg debugger. But I am going to show you how to use this application to debug password.exe. For lab 7, you're going to use x32dbg to debug lab7.exe. So different files, but you basically you're going to do the same thing, okay? Okay, so with that being said, I personally recommend that you use Ghidra in order to debug this code. Although Ghidra is not a debugger, okay, that's gotta be very clear. Ghidra is a disassembly tool. It's a disassembler, okay? So it doesn't allow you to debug a code. However, it's always very helpful to combine a disassembler with a debugger. Is it possible to debug a code using purely a debugger without using a disassembler? Yes, it is. It is possible. However, it's much more difficult. Okay, so the combination, and it's not possible to debug a code by simply using a disassembler. So the combination of those tools is always beneficial. However, out of the options that you have, or the most common options that you have as far as disassemblers, IDA Pro and Ghidra, yes, you can use either IDA Pro or Ghidra, but I strongly recommend that you use Ghidra. You're going to see that it's actually pretty simple to do what you're going to need to do, or it's very helpful at least to do what you're going to need to do when you use Ghidra compared to IDA Pro. So that is why we are going to use Ghidra, and I already have Ghidra open here. Okay, and there you see that it shows password.exe, so the file is open here. Okay, now in case you don't remember, password.exe, this is a code that will basically, when you run it, it will ask you for a password, and if the password that you inform is not correct, it will tell you, hey, the password is not correct. If the password, if the password is correct, it will display a message saying, yes, password is correct, okay? Now, in our, the first time that we analyzed the password.exe file, right, we learned how we could patch the code, right, in order to deviate the execution of it, in order to bypass the authentication process, right? So basically, there was a conditional jump, right? I don't know if you remember, but the conditional jump was J and Z, and that J and Z conditional jump would either take you to a function that would say password is wrong, or something, I don't remember what it says, but I think it says congratulations, or password authentication, password successfully authenticated, something along those lines, right? And then what we needed to do was to change that J and Z conditional jump to simply JZ, and then apply the patch, right? So we didn't actually identify what the correct password was. We just cracked the code, right? Modify the code, apply the patch to modify the code, and force it to take a destination, take a path that would bypass the authentication process. Now, here, what we are going to do is we're going to use this debugger in order to actually learn what the password is. Okay? So, okay, let's see what we are going to do here. Okay. The first thing that I'm going to do, and this is always helpful in order to help you identify where you are located in the code. So look what I'm going to do. I'm going to go here to the text section. As you know, the text section is where you have the code, the actual source code or the assembly code. And one feature that I have, and it's also available in IDA Pro, but I am using Ghidra, and what I'm going to do is I am going to rename this function here. So I right-click, I select the function name, okay, and I right-click and go to Edit Label. Now, I'm going to edit label, and I am going to label it entry point. Okay, there it is. Now, let's understand the reason why I am renaming. Well, I'm not renaming, I'm labeling, okay? So I'm not actually changing the code. I'm just defining a label here. So I'm relabeling this function to entry point, okay? Okay, before I explain why it's defined as entry point, let me go down here. And yes, this one. And I am going to label this one as, I'm going to right click, edit label, and I'm going to label it main. Okay. So, okay, what is going on here? What is the difference between entry point and main? And again, this might be very confusing because, as you might remember, IDA Pro names the main function as entry point, whereas Ghidra names it as main. Okay, so but there is actually a difference between the entry point function and the main function. Okay, so let's understand the difference here. The entry point function, which is up here, okay, the entry point function, I'm sorry. So the entry point function is the function that the application executes, or the instructions that the application sends to the operating system so that the operating system can launch the application. And what does it mean for the operating system to launch the application? That means that the operating system needs to allocate the resources that application will need in order to execute. So it needs to allocate enough memory, right? Enough memory space. It needs to create a stack and stack frames so that the application can execute, it needs to import the the binary code or the instructions, right? And import those instructions to the main memory so that the CPU can fetch those instructions and execute what needs to be executed. So it's the entry point function, is the function that contains the code to allow the application to request the operating system its actual execution. Whereas the main function, and you might be more accustomed to the main function. The main function is the function that will actually, let's say, interact with the user, that will actually start the execution of the application as far as what its objectives are, right? So what is the application doing? Okay, so this specific application, the first thing that it needs to do as far as the actual execution or its objectives, right, is to ask for, display a message. First of all, display a message saying something like, please type the password. So if that is the first thing that the application needs to do as far as its objectives, that is the main function. Okay? Okay. Now that we have labeled the entry point function and the main function, here in the main function, oops, I'm sorry. Here in the main function, you must remember, again, this is one of the benefits of using Ghidra, right? Whenever I place my cursor here in an instruction in the assembly code, it will show me that same instruction in C here. Well, if I have the decompile window open, it will show me what that code corresponds to in the C language, right? Okay. Now, observe that here there is this function fun 00401150, and then please tell me my password. Well, what is the function that is going to most likely, what is this function doing? Well, if there is a function here that combines with a string, and we know that this string is being displayed when we execute the code. So this means that this function here is actually the printf function, right? So what I'm going to do, and here's the function right here, what I'm going to do is to label it as well. Oops. Oh, jeez, I messed it up. Sorry. So let's go there. Here it is. Right click, edit label. This is the printf function. There it is. Observe that here in the C code, now it says printf, and there is another printf here, there is another printf here. So now every time that the fun, and I don't remember what the name of the function was before, but fun, whatever the memory address was, it now shows as printf. Similarly, I know that this function here is the scanf function. And the reason why I know that this is the scanf function is because, well, every time, if you remember how printf and scanf works, printf is just displaying a message. But in order to capture what the user is going to type after the display message is displayed, I need the scanf function. So if the printf function is here, and then the idea is that after this message, please tell me my password, is displayed, I want the code to capture what the user types, I need scanf. So again, that means that this function here is actually scanf. I am going to label it as scanf. Okay, now two things. First of all, remember, we are not patching the code, we're not modifying the code. This is just labeling, okay, for visual identification, for orientation. And that is this keyword, orientation, is the reason why we do this, okay? This has no impact on the execution of your code or the how you are debugging your code. However, this is helpful for you to identify what's going on. If, let's say that not today, but then tomorrow, next week, within a month from now, you need to go back to this code. Most likely, you won't remember some of the things that you already observed in that code. If you do these labels, if you create these labels, it might help you identify what's going on there. Okay, it's just like comments. The idea is the same as inserting a comment. Okay? Okay. So now that's done. Here's what we want to do. We know that what happens, and let's go here to the C code first. Okay? We know that what's going on here is, well, it will display a message, please tell me my password. It will scan that password, the password that I type, okay? And then it will go back to the entry point function. Then it's gonna go back here, and then it will print the message that says the password is correct, congratulations, or the password is not correct. No, it says no, try again, right? Now, observe that at this location here, right, we have the strcmp, which you might remember that it stands for string compare. So I know that at this point here, and you can also label it if you want, okay? If you want to label it to whatever. So if you want to label it to string compare, for example, you can do that as well. Okay, but anyways, I know that at this point here is when the string compare is being done. Now, what does it mean? Why is it doing a string compare here? Well, as you know, it asked for a password. I typed what I believe to be the correct password. And then it compares a password. What is the password that it's comparing to? Well, most likely it's comparing the password that I typed, right, with the password that is the correct password. Now, you got to remember that when we analyzed this code, we were not able to find the actual password. I don't know if it's ciphered or encrypted. I don't know if the password is in a file, stored in a file in the disk. I don't know where it is. But what I can see here is that, well, the password that I type is being compared with another password. If I can find out, okay, I know what I typed, right? I know what I typed. Let's say that I type ABC, okay. If it's comparing ABC with something else, well, then that something else is what I need. That is the password. So what that means is that somewhere around here is where the comparison is done. Okay? So if a string compare, now we go back to the assembly code. If a string compare is being done here, right? So it's the string compare function is being invoked here. Observe that the string compare function is being invoked here, but it's not where the actual comparison is done. Okay? So then we look at the next, the other lines that we have down below, right? And we can see some other stuff here. And observe that here, there is a test, right? And we finally have the JNZ conditional jump that we patched, that we modified, right, the last week in order to bypass the password verification process. So look, if a string compare is invoked here, okay, and the conditional jump to decide whether the password is correct message is displayed or the no, try again message is displayed is here. That means, and there is a test here, that means that this is the test mnemonic that is actually testing if the password that I have, that I typed, matches the correct password. So it's somewhere around here that I would be able to debug my registers and memory addresses in order to identify the message, the password that I'm looking for. So that's exactly what we are going to do. Okay, with that being said, I am going to go here. I'm going to open my my browser, my folder browser. Okay, and here, this is in the practice labs, obviously, right? If you're not using the practice labs, if you need to use a debugger, you're going to have to download it yourself. Good news is most of these debuggers are free. They do have, some of them do have commercial versions, but they also offer free versions with a few limitations, but you can still do everything that we're going to need. Okay, so I'm going to go here, Flare, and here you're going to see the debuggers folder. I'll double click it, and here is a number of debuggers. We are going to use the x32dbg. So I'm going to double click it. There it is. Now it's open. And I'm going to go here to this folder, open file, and I select the portable executable file that I want to, where is it? It's in the desktop. The portable executable file that I want to debug. There it is. Okay, here you go. Now, password.exe, that's the code that you are debugging. Just a few important information here. You can see a bunch of tabs, but we are only going to focus on 2 tabs. Actually, we're going to focus on 1 tab, but initially we're going to need also this other tab here. So the 2 tabs that we're going to focus on are the CPU tab and the memory map tab. Okay, the memory map tab is the tab that will show you the mapping of your memory address. Okay, so what that means is what that means is the reason why we need to take a look at this is because of the memory addresses. Why is it important? Because you might remember that whenever you're inspecting a code using a disassembler such as IDAPRO, right? The code, the stack will always start with memory address, will always be in memory address 401000. Okay? So it's always 401,000, always. Well, obviously, you already realized at this point that is not accurate, because if you think of the physical memory, right, your RAM memory, as a hardware component that has many blocks, and each block has an address. If you launch application A, and application A goes to memory address, or the beginning of this application is loaded into memory address 401000, and then you launch another application, application B, that is also being imported to memory address or beginning at memory address 401000. Well, you can't have two applications using the same addresses, right? So that is because those are virtual addresses, okay? As far as the physical address, which means the actual address in the actual block in the main memory, this is where you can gather that information, identify that information, okay? So here, the memory map represents a mapping of our physical main memory, not just related to this application, okay? Now, you only see these information, these addresses here because I am debugging password.exe, but the address here, which is 012D, 012D0000, that's the physical memory address where the application begins, okay? Obviously, it uses more than that. So you have the other addresses. That is the only situation, at least for this initial analysis or this initial debugging task, that's the only situation where we're going to need the memory map. So now observe, how can we debug a code? Which means how can I inspect the values, the data that is stored in my main memory? If I use, going back now to the assembly code in Ghidra. So what I'm saying is all of these addresses that we see here, right? All of these addresses, if they are virtual addresses, that means that if I try to retrieve the data that is stored in my physical memory, right? If I go to physical memory location 40103F, I am not going to find this. If I go to memory address 040172, I am not going to find this call function here. Okay? It's not going to match because, again, this is virtual address. This is not the actual physical address. So what I need to do in order to use Ghidra or IDA Pro as an auxiliary tool is to make this address match the actual physical address. So I can close this. And let me go back here. Again, the address is where, so I go to the line where the application name is shown. So the application is password.exe. This is the memory address that I need. 012D0000. If I got the number of zeros right. 1, 2, 3, 4. Okay, so 012D. Now what I'm going to do is I'm going to go here to Ghidra and I'm going to click here, display memory map. Observe that the code begins at this. I am going to change it, and to change it I click on this button here, set image base, and I am going to change it to 0012D0000. Hit OK. The mapping has been redefined, and when I go back there it is. 012D. Oh, that's the entry point. Let me go to the beginning of it. Here it is. No, not here. Headers. 012D000. The code is at the text sections. I'm going to go back there, and you're going to see that the entry point function begins at 012D1000, which was before 00401000. Now I can rely on these addresses here. So what that means is, in the debugger, if I want to find the location where the, let's find here, the main function, right? In the main function, I'm looking for the location where that test is done. Where is it? Where is it? Here it is. So what I need to do now is to start debugging my code, and I want to insert a breakpoint at this address here, at this memory address here. Okay? Before it was 00401008B. Now it's been redefined to the correct memory, physical memory address, 012D108B. This is the memory address where I want to insert a breakpoint. Okay? If I go there in the debugger, I am going to see this assembly code here. Okay, so let's try. I'm going to go here to CPU, and I want to identify that location. Oh, go here. I'm going to double click the text section here. And now I will try to find, what is it again? I forgot. 012D108B. I think that's what it is. Let's go back there. 8B. 08B. Okay. 08B. Here it is. There it is. So, okay, now, as far as breakpoints, how do breakpoints work? A breakpoint is nothing more than a location, a specific location where you want to freeze the execution of the application. So, when you first open a debugger and you say, debugger, this is the application, the portable executable file, for example, or the dynamic library that I want to inspect, whatever the file that you're trying to inspect, right? This is the file that I want to debug. What the debugger is going to do is it will launch the application, but it will freeze it at the main function. That is why it was so important to identify the entry point function and the main function, because the debugger is going to freeze it at the main function, the beginning of the main function. Okay, so actually the application is frozen, as you can see here. I did not execute password.exe at any point in time. It's only shown here because when I opened password.exe file with my debugger, the application was launched at the same time. Okay, so it's frozen. Now, here in the debugger, you can see, and in the previous video, you saw the different types of steps, right? So you can do step into, you can do step over, so you have all these different types here. But you can also do the run. And what run is going to do is it will simply execute the application as if you were invoking the application or double-clicking the application. So it will execute everything. If there is a point where it needs to interact with the user, then it will freeze there and wait for the user interaction. Other than that, it will just execute all of the assembly instructions. Well, actually, all of the opcodes, all of the binary instructions, okay, one after the other. Obviously, that is not what I want to do because I want to force my application to freeze at this point here. And as you can see, breakpoint not set. I am going to simply click on this circle here. There it is. I set a breakpoint right there. Okay? Now I can run my application. So I'm going to click there, run. And it froze at the beginning of my application. That is because the application is going to ask for the password, right? So there it is. Please tell me my password. I'm trying ABC, okay? And I'm gonna hit enter. Okay, nothing happened. Let me go back there, okay? Nothing happened because it's not that nothing happened. It's because after this scanf function, that's when I type my password, the password that I believe to be the right password, it will continue to analyze all of the instructions until the point where it finds a breakpoint. So at this moment, it's right here. And if you look at the status down below here, it says paused. It's paused again because it found a breakpoint here. An interruption 3 breakpoint is a software breakpoint. You got to remember from the last video that we have the conditional breakpoints, we have hardware breakpoints, and we have software breakpoints. This is a software breakpoint. A software breakpoint is represented by an interruption 3 breakpoint. Okay? So interruption breakpoint at password.01 to D108B. Memory address, this one. Okay? Okay, now, there is somehow I know, that the password that I typed and the correct password is stored in a memory address or in a register at this point. Now, in what register or in what memory address? First of all, you got to remember that a register is a very small storage space, right? At most 64 bits long. But this is not 64 bits architecture, so it's at most 32 bits long. 32 bits long, that means 4 bytes. Well, most likely, the password is not only 4 bytes long, right? So what that means is that probably we have a register that contains the memory address where the password is stored. Correct? Observe, we are at the CPU tab. What we are analyzing here are CPU instructions. CPU does not directly interact with the main memory. It uses its registers to interface, to communicate with to exchange data with the main memory. So if the main memory, if the password is stored in the main memory, there's got to be a register that has the address to that memory location. So if that's the case, I need to look at the registers that come before the test. And I can see 2 registers here, EDX, ECX. We know that it's not going to be ESP because ESP is the special register. It's not a regular data register or a general register. So, okay, most likely EDX, ECX. Oh, there is also EAX here. Yeah, okay, fine. We could try that as well. Okay, but EAX is also used up there. So, let's start with ECX. What I'm going to do here is, if I want to inspect the content of ECX, I click there, then I right click, and I go here in following disassembler, ECX. Okay? And down here below, it shows the content of that register. And the content of the register is this memory address here. And in this memory address, the content is 8B4424CC C204. Okay? Now, obviously, this is in hexadecimal, which is not helpful. Now, there is another catch here, and this is something that I'm going to show next class. This hexadecimal is actually encoded. That's because this code, this password.exe file, ciphered the text. It didn't cipher. It encoded the password using a XOR encoding. Okay? But I'll show you how to decode it. Obviously, in order to decode something that's been encoded, you need a key, and I'll tell you what the key is. Okay, so I need to write it down, but it's here. Okay, so let's just remember that. And I am going to open the browser here. So at this point, I don't believe I need I don't need Ghidra anymore, so I'll just close it. I'm going to open my browser here and search for CyberChef tool. No. Okay, accept all. Here it is. Again, you don't need to worry about this at this point because I'm going to show how this tool works next class. Okay. But again, oh geez, the format is all messed up. How can I fix this? That's not good. Okay, let me hold on just a second, and I'll use my own browser. Okay, so let me, where is it? Okay, here it is. No, here it is. There it is. So I opened in my own browser here. Okay, so I open it in my own browser here. So basically, again, I'm going to show you how to use this next class. Okay, this is an online free tool that you can use to decode code, encode or decode several types of codes using several types of encoding algorithms. Okay, again, I know, and I didn't explain it yet, but I will explain, but I do know that this file encoded the password using a XOR. So what I have here is, well, I have a code, an encoded code that is hexadecimal, okay, and I want to decode it using the XOR logic operation. I also need a key, which I know that it's 6C. You don't need to worry about this. Again, I'll explain. Okay. What I need now is the actual input, the actual encoded password, so that it shows me what the decoded password is. Okay, now I'm going to go back there. And let me fix the window here. There it is. Okay. And okay, I messed it up. I clicked on follow disassembler, I believe. Okay, so let me go back there. Here it is. Let's find the line 8B, right? Here it is. That's where my breakpoint is. And I want to inspect the ECX register. So I right click on it. It's following dump. I believe that I clicked on following disassembler. It's not in disassembler. It's follow in dump. Okay. Selected address. I do not want to follow the selected address. I want to follow the register, which is ECX. There it is. Oh, now it's correct. Yeah. Okay. So ECX has, here's the content of my registers at that moment. So this is the content of all of my registers at that moment. Okay. And ECX has 012EE000. We can clearly see that this is a memory address. Now, what is the value of that memory address? What is stored there? It's 1B0415025C18. So that's what I'm going to do. I just need to memorize 1B0415, 1B0415. So 1B0415, what else? 02 5C18, 025C18, 025C18. With that key, the output, the decoded password is why not with 0 instead of O. Okay, let's see if that is the case. So let me go back here. Okay, and I'm going to run the application. The password is correct. Congratulations. Okay, so as far as the debugger, what are we looking at here? We saw that we can actually use a debugger to inspect the values, the actual data that is stored in registers, in memory addresses. Okay, you can do the same thing for memory addresses as well, just like you can see the memory addresses here. Okay, so that's why debuggers are so useful and so important, because you can look at the values that the application is using during its execution. Now, once again, don't worry about the encoded password. I will explain to you why that's going on. I will explain to you how I know that was the case. But it has nothing to do with the debugger. Okay, this is just an implementation that the malware writer did, but that's another resource and we'll look at that. Okay, so as you can see, it's not difficult to use a debugger. It's actually pretty straightforward. Now, one mistake that I did here, and I need you to remember that when you want to inspect, you're going to right click on the storage that you want to inspect, whether it's a memory address or a register, and you're going to go to follow in dump, not follow in disassembler. Okay, and then you select it there, and you're going to see the values in hexadecimal down here. Thank you guys. See you next week.